Hi, this is Miss Merced, and this is the last part of the lesson, right triangle similarities. So you're going to want to take notes on all the key concepts here. There's about 3 slides of key concepts and then 2 slides of examples. So here's the first slide. This theorem states that the altitude to the hypotenuse of the right triangle divides the triangle into 2 triangles that are similar to the original triangle and similar to each other. So the altitude, when we look at the big triangle here, the altitude is from C to D. Okay, altitude goes from the vertex and goes straight down and hits at a perpendicular angle to the opposite side. So basically, ABC, this big triangle is your right triangle, and with the right angle ACB. And CD is the altitude to the hypotenuse. And then what happens is ABC is considered similar, the big right triangle is considered similar to the smaller one it creates, which is angle ACD. And ABC is also considered similar to the medium triangle it creates when you split, if you use the altitude as a division, a dividing, and split the 2 little triangles into 2 separate pieces. The medium-sized triangle is similar to the bigger triangle, and then the medium-sized triangle is similar to the smaller triangle. So that's what this theorem is stating. Please make sure you take the time to read this, understand this, and write this down. I would highly suggest writing down all the diagrams that are shown here and all the writing and the symbols here. Okay, and then here's our next one. So this is the corollary to the last theorem. So the length of the altitude, we're talking about the altitude CD, if the length of the altitude to the hypotenuse of the right triangle is a geometric mean of the length of the segment of the hypotenuse. So geometric mean, basically, as you see down here, you have the x here to x here. So those are the same, and then you have 2 different numbers here. So basically, we're looking at the segment hypotenuse, and this here, if we look at the example on the left, this 2 is representing the smaller part of the hypotenuse, and this 8 is representing the larger part of the hypotenuse. I mean, together they're the whole hypotenuse. And then the 4 is representing the altitude. So the altitude of the hypotenuse. So the 4 is being repeated, and then you have the smaller part of the hypotenuse versus the bigger part. Okay, so we're just saying that the ratios are proportional to each other when you have the smaller part of the hypotenuse over the 4 versus the 4 over the bigger part of the hypotenuse. Okay. Here's the next corollary. The altitude to the hypotenuse of the right triangle separates the hypotenuse, so the length of each leg of the triangle is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to the leg. Now, this is a lot of wording, and we will practice this more in class, but I want us to write this down now so we can just do straight practice, and we will talk about it more. So we are comparing the hypotenuse and the legs now. In the last one, we were comparing the hypotenuse and the altitude. In this one, we're comparing the hypotenuse and the legs. So what we're saying is the hypotenuse, and here's an example. This big hypotenuse is a 4, and then we're comparing it to the smaller part of the hypotenuse versus the leg. So the leg in the hypotenuse of the big triangle is actually really considered the hypotenuse of the smaller triangle, and then it's used twice, and then here we have the 2 and over the 1. So if you see the similarities, I don't know if you can catch it, but this hypotenuse in this big triangle is 4. But when we only look at the smaller triangle, the 2 and the 1, like the tiny one, the actual hypotenuse is 2. So if you see here, this is a hypotenuse of 4, and then this is a hypotenuse of 2. And then we're comparing the hypotenuse 4 with the leg 2, and then we're comparing the smaller hypotenuse 2 with the leg 1. So I don't know if that probably was even more confusing. Please go ahead and just write this down, and we will talk about it more in class. Here are 2 examples that I want you to write down and see if you can try to understand them. So you can take your time. You can pause this video and rewind and take your time with these examples. So they're asking us what is the value of x, and we can use our corollaries and theorems that we just learned in order to answer that. So with the proportion using corollary 2, we're using x twice, and here, if you really critically look at this, basically this x is kind of having a different definition depending on the triangle that you're looking at. And then we're taking the hypotenuse, the big hypotenuse 4 versus the smaller part here 4. Okay, and then they're cross multiplying. They did 4 plus 12 is 16. Then they cross multiply. You get 16 times 4 and x times x. X times x ends up being x squared. So when you multiply 2 x's together, it's like saying x squared. And then 16 times 4 is 64. In order to solve, we want to square root both sides. And so the square root of 64 is 8. So the answer is x equals 8. Here we are trying to solve for x, and the answer is x equals 8. Here's another example, and instead we're solving for y. Now they're using corollary 1. Y is listed twice. We have 4, the smaller part of the hypotenuse, and 12, the larger part. And we're using cross product, so 4 times 12 and y times y. 4 times 12 is 48, y times y is y squared. We want to solve for y, so we're going to square root y squared. Whatever we do to one side, we always do to the other side, so that's both sides. Here we cannot square root 48 and get a pretty whole number. So what they're doing is finding factors of 48. They're saying what times what gives me 48, and I can square root it. So it looks like the factor is 16 and 3. So if you were stuck here and you weren't sure, you would just have to ask yourself what times what gives you 48. 48 times 1 gives you 48, and 16 times 3 gives you 48. So I'm sorry, I'm trying to write this 48 times 1, and then 16 times 3 gives you 48. 48 and what else gives you 48? 12 and 4 give you 48. 24 and 2 give you 48. 6 and 8. These all multiply up to 48. Okay, 48 times 1, 16 times 3. So what you're trying to do is figure out which is the highest one that you square root, because what ultimately the goal is that their final answer is 4 square root 3. The reason they did that is they just want to make their square root more simpler, but it ended up being a decimal when you square root 48. So they're just like, okay, well, how can we make it a prettier package without making it a decimal? So they're trying to think about what factors of 48 could they possibly square root to get to get something that you can square root out. So the ones that you can square root are 16. You can square root 16 and you get a 4 out. You can square root 4 and get a 2 out. You can't square root 2. You can't square root 12. You can't. So nothing else. Only 16 and 4. And you want to see which one you can square root the most out. So it looks like when you square root 4, you only get 2 out. But when you square root 16, you get 4 out. So that's how they're doing that. They're basically saying the square root of 16 ends up being 4. So they put that outside. And since 16 times 3 gave 48 and we couldn't square root 3, if you square root 3, you get a decimal. We're not going to do that. They just leave it under the square root. So that's how they got this answer. They're just leaving what they can't square root under the square root. They're leaving the factor that they can't square root to a pretty whole number under the square root. And what they could factor out, they factored out. Okay? That is all for your notes. Please make sure you wrote everything down, and we're going to go over it in class. Thank you guys. Have a great day.